So we have some slightly simpler approaches. We've got fault tree analysis and event tree analysis. And so you imagine we've got this picture here that you've got the initial undesired event. So fault tree analysis is what leads up to that event occurring. So that deals with everything on this side. Event tree analysis, that deals with everything after that has occurred. So I suppose I probably should be this way around in your image if you can see the PowerPoint in my picture. So fault tree tries to prevent, is used to try to prevent the fault occurring in the first place, and you address the things that will contribute towards that fault occurring, which is usually multiple different causes. Event tree analysis is you assume that the fault has occurred already, and then what are the consequences of that fault? And so you then have results which might be undesirable, or you might, if something fails and then some safety mechanism comes into play and it operates successfully, then you've got you don't have the undesirable consequence. So got a good example here, which is being late to work. So here we have fault tree. So we're talking about the car not starting. And so what fault tree analysis does, and they've got, you see these the shapes of these little gates. You have OR gates and AND gates. And what it's saying at an OR gate is if there's no gas or there are no electrics operating in your car, then the car will not start. So that's an OR gate. You notice here that they put a probability on each. So no gas, no petrol. The probability is 0.003. No electrics, the probability is 0.001. So relatively low probability, 1 in 1,000. If you combine the two of them, say either there's no gas or there's no electric, then the probability of your car not starting is 0.014, which, if you look at it and think about it, actually means there's it's a significant concern, and it's a good chance it's going to make you late to work in over a given year. So you might want to consider putting in place some measures further upstream of this final fault, this final undesirable outcome, and in order to reduce the probability of either there being no electrics or no gas. And so we've got OR gates and we've got AND gates. So here we're saying if there's no gas in the tank and you have no gas in your spare can, then you're going to have no gas. So you get the general idea. And ironically, if you lose your keys, well, there's not really much that you can do about that. I think possibly you could add cannot find key, cannot find spare key. And so that would be an AND gate. So you're getting the general idea. We use these things called Boolean operators. So fault tree analysis just uses AND and OR gates. It doesn't use any of the other options you get under Boolean or logic. So if you think about it, if you've got more OR gates in a system as you model it, then you're going to find it more you're going to have it more likely that you're going to end up with your final undesirable outcome. So more AND gates equals a more reliable system, because two things have got to go wrong for an AND gate to trigger, whereas for an OR gate to trigger, only one of the two things needs to go wrong. Now it's fairly restrictive, because if you think about it, each and every gate, it's just binary. It's there's only two different things that can go into it, and it isn't half time consuming. It's very time consuming, and so it's worthwhile again if the severity of the outcome merits this level of analysis. Now you notice here you can add you can have it either as qualitative, just to model it to help you picture it all, or in qualitative methodology, or you can go quantitative and add probabilities at each stage, and then just use a little bit of calculation to work out what the ultimate probability is of your car not starting. Interesting, its first year use was on Minuteman missiles. Now, entry analysis, as I said before, it deals with something going wrong at the start, and then does that. If something goes wrong, does that then lead to your undesirable outcome? So here we have the classic situation of ending up late again to work. So get up late. Does the car start? Yes or no? If it does start, is the freeway, the motorway clear? If it is yes, then you're in work. That's fine. You make work on time. If it's not free, then you're late again. You see here, it's only OR gates. There's no AND gates at work here. But again, it's quite binary. And again, you can add probabilities to each stage. To some extent, this sort of thing doesn't cover stuff with gradually increasing variables. It's all quite binary, and it's a